Hey, welcome back to Math with Patrick and Quill. Today is April 17th, and we have problem number 107 to solve today. So we just need to show, there aren't instructions here, but I'm guessing we need to show why n should be 17. Usually in this calendar, they use x as like the variable to solve for, as like the assumed answer, but I don't think they've actually used an n as the assumed answer without any instructions attached. So, oh well, it's just a small difference, I guess. So let's solve for n today and show why n should be 17. Well, apparently 9 to the n plus 9 to the n plus 9 to the n is equal to 3 to the power of 35. 3 to the power of 35 is obnoxiously large. I think that you could plug it into some calculators, but other ones wouldn't really like it. It's a very, very big number. It's 35 threes all being multiplied together. And just to kind of show you a sense of scale, I can count by my powers of 3 up until a point. So this is 3 cubed, 3 to the power of 4, 3 to the power of 5, 3 to the power of 6, and then I kind of lose track after this. And then, so that's only 6 steps in, and 3 to the power of 35 goes way further. And you can kind of tell how it's like growing pretty quickly from like 3 to somewhere in the hundreds. Just imagine what it would be after like 29 more steps. So instead of like trying to figure out what this number is directly, I think I'm just going to try to figure out how to match the base, as in the base of 3, with a 3 over here. And fortunately, these 9s like kind of feel like a 3 to me, right? It's like 3 times 3 to get to each of the 9s. And so I'm going to try to write the left side as some kind of power of 3, as in 3 to the power of something is going to be 3 to the power of 35. And then I'm going to try to match up this with the 35 here. So let's kind of like talk about what 9 to the power of n is. Here it's like I don't know how many 9s I'm multiplying all together. Maybe it's going to be 9 cubed, which will be like 3 9s all multiplied up. But like I said, I wanted to match the base of a 3 because the 3 is already there on the right side, so I want to put it here somewhere on the left side. So instead of thinking of 9 cubed as, well, like 9 cubed, I could think of it instead as 3 to the power of 6. That's because I can kind of like break apart each of these 9s as 3 times 3. And so 3 9s multiplied together, it's going to be the same thing as 6 3s. And this 3 I chose here is kind of arbitrary, right? Like it could have been a 4. And so if I put another 9 here, looks like I tack on 2 more 3s, and this 6 should change to an 8. Essentially what I'm getting at is that I can convert my base from a 9 to a 3 as long as I double my exponent. And I can even show that through some algebra steps too. So I'm going to claim that, well, it's not that hard of a claim to prove, but 9 is the same thing as 3 squared. And that's all I'm changing here for now. I'm just saying that, yep, 9 is the same as 3 squared. That's fairly straightforward. And then the next step I'm going to do is a little bit harder to prove, but I was trying to show it to you there with like how the exponent of 3 turned into a 6, how the exponent of 4 turned into an 8. And so if I change my base to a 3, my exponent should double. And there is an exponent rule where if you have these stacked exponents, like 3 to the power of 2, then to the power of n, you're allowed to multiply the 2 and the n. Or, if it was like some base to the power of x and then to the power of y, you're just allowed to multiply those two numbers together. So that's an exponent rule that I am kind of employing right now to try to solve this problem. And so this is still going to be equal to 3 to the power of 35 on the right side. And well, I have 3 things being added up. So if you kind of trust me that like x plus x plus x is 3x, then hopefully you can trust me that 3 to the 2n plus 3 to the 2n plus 3 to the 2n is 3 times 3 to the 2n. And so I'm super, super close here. Like I have so many 3s here. And what I wanted to do was get just, 3 to the power of something on the left side. I didn't really want some extra stuff going on here. I really just wanted this with maybe some kind of exponent there. Fortunately, 3 to the power of 2n basically just means a whole bunch of 3's all multiplied together. I have 2n of them. And so if I finally multiply on one more 3, well, I could just write that in the exponent. I could do 3 to the power of 2n plus 1, because I have one more 3 right here. And then I've achieved that goal of matching my bases. They're both 3 now. And so, again, I don't know what 3 to the power of 35 is, but I do know that 2n plus 1 has to match 35, and this is a much more approachable problem to me. I know I could subtract 1 from both sides, or like in other words, this 2n has to be the number 34, because when I add 1 to it, I get 35. And just the way I'm going to represent that is with these algebra steps of like undoing the plus 1 with a minus 1. So I know 2n has to be 34. And then kind of same dealio here. It's 2 times some number equals 34. I kind of just know that n is 17. Like I know 2 times 17 is 34. I could also express this as like doing the opposite of multiplying by 2 to both sides of my equation to isolate or get by itself this n right here. And yeah, here's that 34 divided by 2. That's just 17. And that matches today's date. So n is 17, and scrolling back up, I could plug it right back in here, here, and here, then do 9 to the power of 17, don't know what that is, add all of these up together, and it's going to be the same thing as this really big number as well. And yeah, no clue what that number is, but I do know that n has to be 17 for today. To me, the key takeaway from today's problem is just like how to solve these problems when you have some kind of base to some kind of power of an exponent. It's like not that important to figure out what number you're solving for, and rather it's more important to figure out how you can match the bases on both sides of the equation. Because if you can do that, then lining up the exponents tends to be a little bit easier. So that's all from me today. Thanks for solving this problem with me. I'll see you tomorrow. All right, bye.